So the left-hand side, guys, will that be plus 14?
No.
No, it will be how much?
Plus 12.
It will be plus 12. Again, we assume that it's x, and we saw that the total was -2, and that's what it's telling us that this side is plus 12. So guys, if this is plus 12, you see that plus 12 belongs to 2 chromiums, right?
Yeah.
So if 2 chromiums have $12, each one has how much?
$6.
$6. So plus 6 is the answer for chromium. And oxygen, what is going to be the answer? It would be,
-2. Right.
yes, so it should be again per atom. So it's -2. Okay. All right. Guys, questions on this? Okay. Now, guys, one more example here. So K2CR2O7. Can you find me the charge of K, CR, and O? What do you see different in this question versus the other questions that, guys, we just did?
We have another
There's
element.
3 different atoms.
We have 3 different atoms, right? Okay, keep it as simple as how we were doing the other problems, actually. Whenever you see 3 atoms, guys, remember from nomenclature, what does that indicate? What should you be looking for?
Polyatomic.
You should be looking for polyatomic ion, okay? So in K2CR2O7, do you see any polyatomic ion, guys?
Yeah.
Dichromate.
You see dichromate. And what is dichromate?
CR2O7.
CR2O7 with a
And
-2 charge,
Yeah,
right?
-2 charge.
And potassium is, of course, K+1, right? So guys, whenever you see polyatomic ion, you can actually break that molecule into its ions, like K+ and CR2O7 -2. Once you have that, you already have the answer for potassium. And CR and oxygen, we just did that in the previous example. You guys see that? We just did CR2O7 -2. So you see, even when you have 3 atoms, you can simply make it like a 2-atom question. Does that make sense, guys?
If we have 3 atoms, will it always be a polyatomic ion? And
Yes,
we'll
yes.
never have to calculate 3, right?
No, you never have to calculate 3. Now, even if you have to, okay? So this is one method where you split it. Since you asked me, there is where you can actually find the charge by keeping all these together, okay? So let's first finish the answer so that you guys know that you all understand this.
So on, this is one of the exceptions, right?
No. This is not any exception. This is just where you have more than 2 atoms. Okay. This is no exception. You're still following the same rules of finding the charge.
Okay.
All right. So potassium, guys, what's the answer for potassium?
+1.
It's +1. Because remember, guys, potassium was type 1 metal, and it was always going to be +1. We knew that from beginning, right? Now, tell me, CR was how much? We did that in the last problem. CR was?
+6.
+6, and oxygen was -2. So it's still that same thing here, okay? Any questions so far, guys?
For oxidation state, if there are elements that are already known, right? Do we have to do this? Or?
Like type 1, type 2, we already know they're the charges. Now, when you're saying, if you're thinking oxygen, like, do we have to figure out that it's -2, or can we just blindly put every time it's -2? Sometimes we cannot. Okay, sometimes we actually cannot. There are going to be cases where you're going to see that the charges are not going to match. We're going to do such examples, okay, where you're going to see carbon is not +4. It's going to be some
but
other.
As long as you start with the element to the right and then you calculate it, you should always be okay.
Yes, exactly. And then just to be more confident with our rules, we must look at this table. Okay, so let's read this. Read the rules for assigning oxidation state. So the very first rule that we already learned is this: that the oxidation number must add up to the charge on the molecule, formula unit, or the ion. So what is this trying to say? Like, remember, the charge of CO2 was 0 on the top. So the charge of X and the right-hand side, let's call that Y. X plus Y is equal to 0. That's what this first rule is trying to say. Does that make sense, guys? Like, let me write that here again. Like, for instance, the second example, SO4 -2. What this is trying to say is that X, write that again. So X, if I split this into half, if this side is X and this side is Y, this rule is trying to say that the oxidation number must add up to the charge on molecule. So the oxidation numbers, X and Y, must add up to this number on the top. Does that make sense?
Yeah.
Yes?
Yeah.
Okay.
Yes.
Right. Now, so that first rule is just simply saying that. Now let's look at the second rule. The second rule is the atoms of free elements have oxidation number of 0. Now we have learned this before, okay? Let me mention that here again. If I ask you guys, what is the charge of this carbon? What is the oxidation state of carbon, guys? This carbon. I'm not just saying any carbon. This carbon right here. What is the charge of this carbon? Do you see any charge here?
No.
No. So the answer is 0. If I put that here, guys, if I ask you, this sodium right here has what oxidation state or charge? What is your answer going to be?
0.
0.
0. If I ask you this, now tell me, what is the oxidation state or charge of this sodium plus 1?
+1.
It's going to be plus 1. So guys, it is that simple, okay? So don't overthink on this. So the question is not this, guys. Look here again on the screen. When I'm asking you this sodium has what charge, don't start thinking that sodium on the periodic table has +1 if it ever makes a charge. That's not the question, okay? The question is simply that if you have this exact same sodium that is given in the question, does that have any charge? No, that does not have any charge. So your answer is 0 for that. Okay?
So if they don't indicate a charge, then
Right.
there's no charge.
Yes.
If it's alone.
Yes, when it's alone. So that's the exact thing that you need to remember, that when it's an element and it does not show any charge, it does not have a charge then. Okay? Let me give you one more example. O2, what do you guys think for this guy? Ask
0.
yourself, don't ask yourself if it's by itself. Ask yourself if it's an element or if it's a compound.
Element.
This is an element. And elements are going to have what charge?
No charge.
No charge, 0. So guys, look here again, the second rule. The second rule says the atoms of the elements, free elements, have oxidation number of 0. Does that make sense, guys?
Mhm.
So you're gonna remember, okay? So you are gonna find this simple multiple choice question on the exam where I might just ask you sodium +1 has what oxidation state? You're gonna say it's +1. Or if I ask you O2 or let's say Cl2, what is the oxidation state of Cl and Cl2, guys?
0.
0. Okay. Now, if I ask you this, guys, in NaCl, what is the oxidation state of sodium? What are you going to say?
+1.
It's +1. So when they're in the compound form, that's when you look at the product table and figure out what their charges or oxidation number should be. That's when you compare the left side, right side, and all of that. So, okay.
Mhm.
Right. Questions?
So when they're in a compound, it has a charge, and when they're not, when they're just an element, there's no charge
Right.
when stated.
Exactly. So when they're in the element form, they don't have a charge unless mentioned. And then for when they're a compound, that's when you have to do the work to figure out the charge. Okay. All right, guys. So now let's look at our third rule. Third rule, all of you already know. So what is this saying? Metals in group 1, guys. Guys, group 1 has what charge?
+1.
+1. So it's just saying that again, +1. Group 2 is +2.
+2.
And then guys, group 3, remember we learned aluminum, gallium, and indium. They were +3, +3, +3. So you're going to remember that here as well. So it's not just aluminum, but it's also aluminum, gallium, and indium, okay? Let me add that here. Aluminum, gallium, and indium. So all of these, they have the charge of +3. Now, the next rule, what does that say? The next rule is talking about hydrogen and fluorine. So guys, hydrogen, guys, tell me hydrogen should have what charge?
+1.
Hydrogen should be +1, right? Now, guys, remember, for hydrogen, please remember this. It can be +1 or it can be -1. This is where I was telling you guys that you need to remember. This is one of those exceptions where you have to start with hydrogen, okay? So hydrogen is +1 or -1, depending on what it's sitting with. Guys, tell me, what is hydrogen defined as? Is it metal or non-metal?
Non-metal.
Hydrogen is a non-metal. And guys, what are non-metals good at? Getting positive charge or negative charge?
Positive charge, getting a positive
Negative.
charge.
No.
Non-metals negative because
Non-metals
metals are positive.
negative. Metals are positive, right? Like Fe, you see, it says right here. Fe is positive. metals are positive, non-metals are negative.
Oh, I'm
So-
sorry. I thought you were talking about gaining. What they're
Oh, yeah. Sorry about that. Okay. So hydrogen, this is the actual charge. +1 meaning lost 1 electron, and -1 meaning it gained 1 electron. Okay. So hydrogen itself is a nonmetal. When it's sitting with other nonmetals, for instance, it's sitting with carbon, or fluorine, or oxygen, or sulfur, which themselves are nonmetals. Hydrogen is kind of a weak metal hydrogen is kind of a weak nonmetal in front of other nonmetals. Does that make sense, guys?
Mm-hmm.
So hydrogen, yes, it is a nonmetal, but not that great of a nonmetal like carbon, oxygen, sulfur, fluorine, chlorine, bromine, iodine. Okay, so when hydrogen is in front of other big nonmetals, that's when hydrogen will actually act as a metal and get a positive charge. So hydrogen is +1 with nonmetals. So when it comes to nonmetals in front of hydrogen, hydrogen loses out. Does that make sense, guys?
Mhm.
Now, hydrogen is going to be -1 with what then? With
Metals.
the metals. So if hydrogen was next to iron, then iron is a metal, and that's when hydrogen can act as a good nonmetal and become a negative charge. Okay.
Mm.
So again, you want to remember to have this with you. Again, if you when you're gonna practice this, you're gonna remember this automatically, or you can have this handy when you're giving your exam. Okay. Great. Okay, so let's look at our next example.
What about for fluorine? That you're saying that
Redox.
only for hydrogen, right? Because the
Yeah,
rule
yeah.
says like, okay,
Right. So
fluorine's still always
is
-1.
-1. Yeah, fluorine is
Okay.
always -1. It's the strongest nonmetal. No one beats fluorine. Fluorine is -1 always. Okay. Now, let's look at this example here, guys. Oxygen is -2 charge, and we know that, right? Oxygen is -1 and -2. I'm sorry. But when it's a peroxide, that's when oxygen is -1. Does anyone know what is the formula for oxide? We learned that in polyatomic ions.
O2?
It's
No.
so O2. This is oxygen, right?
Mhm.
Would it be
O2 is
OH?
-2. No. OH negative. That's hydroxide. This is hydroxide. That's different. Okay. We're talking about peroxide. You see, oxygen O2 when it has a -2 charge on it. So this is not just plain oxygen O2 that we breathe in. This is peroxide. This is O2 with a -2 charge. Now, guys, does this thing look like an element to you?
Yeah.
Or is this a ion? Element and ions are two different things.
It's
This
an
is an
ion.
ion. It's an ion because it has a charge, right? So can you figure out if I give you this on the exam, oxygen -2, and I ask you, what is the oxidation state of oxygen in O2 -2 in peroxide?
-2.
Then how will you figure this
Wait,
out?
no.
It would be -1, right? Because in this case,
Yeah.
it's how would we do that actually?
So see
'Cause
here, guys.
you-
Yes. Stephanie?
Oh no, continue.
Yeah. Okay. So O2 is -2, right? What was the? Remember, the charge is always per atom. Does that click here? Why it's -1? Why the answer is -1?
Uh-huh.
So you see, the total charge is -2, and that's -2 on how many oxygens? Guys, that's -2 charge on how many
For
oxygens?
two.
On 2.
2 bucks.
So each one has how much?
-1.
-1.
So basically, you're doing -2, which is the charge, total charge, divided by 2 oxygens that you have. So each one is -1. That's why it's called peroxide, like per as in 1. So this is -1. So this is the time where oxygen is -1, guys. Okay. Question? Now, guys, there's
So-
one more. Yeah, Stephanie. Go
If
ahead.
you were inside a compound or something, how do you know if that oxygen or O2 was peroxide or
that-
normal oxygen?
So a normal oxygen, which is O -2, let's combine that with H plus.
Mhm.
and tell me what do you think you will make. Do the crisscross and give me the formula of what are you going to make. Let me write that here.
H2O.
So oxygen was -2 and hydrogen was +1. If they were going to do crisscross, what do you make?
H2O.
The water, right? So water. So water has oxygen, which is -2. Okay. Now, let me give you this example. Hydrogen is +1, same as it was. Now, O2 -2. You see this is peroxide? O2 -2. Now, do the crisscross and tell me what is the formula?
Wouldn't this be HO? Because they're both going to be H2O2.
Not in the case. So here you actually do not bring it down to whole numbers. I mean, to the lowest whole number ratio. You don't do that. Okay,
Why?
because peroxide is fixed. It's O2 -2, and you cannot change it to single oxygen.
Oh.
Okay. So this is, again, this is going to be one of those times where you do not bring it down to the lowest whole number. And this you have just plain memories, because every time you do bring it down, in this case, you don't. Okay.
So we were finding oxidation state for H2O2. We still start from the right?
If you start, so this is where I was saying, when it's hydrogen, that's when you have the exception. That's where you're going to start with hydrogen.
Oh, okay.
Okay. Also, when you see two oxygens, just be mindful that maybe there's peroxide sitting in there. And you see, guys, this thing here is actually called hydrogen peroxide. Have you heard of hydrogen peroxide?
Yes.
Right? Yes. So hydrogen peroxide is basically this thing, H2O2. Okay.
Can you give an example of when the H is, when hydrogen is negative, when it's H -1?
Yeah, sure. So hydrogen is -1. So let's take that example. So H2 ZN. Or you might actually see that as ZNH2. So let me show you that as the other way. So whenever you have hydrogen, always start with hydrogen, no matter if it's on the left-hand side or right-hand side, doesn't matter. You should still get the same answer.
If we're starting with hydrogen, how do we just use negative or +1 depending on the other element?
Depending on the neighbor, yes. Okay. So here, guys, where should we start? With zinc or hydrogen?
Hydrogen.
With hydrogen, right? So hydrogen is what charge?
-1 × 2.
It's -1 × 2. How did we decide that we're going to go with -1 and not +1?
Zinc is a metal.
Because zinc is metal. And we learned that in that previous rule, that hydrogen, if it's sitting with the metal, that's when it is good at acting as a non-metal. And that's when it will get that negative charge, because non-metals get negative charge, okay? So -1 × 2 is -2. So this makes zinc what charge?
+2.
A +2, okay? So when we knew zinc is a +2, right? So whenever you have hydrogen in there, start with hydrogen.
Okay.
Okay. In H2O, guys, can you find the charge of each one?
Yeah.
So let's say we want to be consistent and want to start with hydrogen. So what charge should I give to this hydrogen? +1 or -1?
+1.
+1. What makes us decide it's going to be +1 again?
It's with a
Oxygen is a
non-metal.
non-metal.
Because hydrogen is sitting with a non-metal. So hydrogen is +1 × 2, making it +2. So that makes this right-hand side how much?
-2.
And we know oxygen is -2, right? So this would have worked either way. You start with oxygen being -2, so this side will be +2, and each hydrogen will be +1. So both ways you will get the same answer.
So the two metals are start with hydrogen first, and if there isn't hydrogen, start with oxygen first?
Yes. So always start from right-hand side except when it's hydrogen.
Okay.
Then start with hydrogen if you have hydrogen. Okay. Now let me give you one more example, guys, and tell me what's weird here. So OF2, again, give me the answer for oxygen and give me the answer for fluorine. So first of all, tell me, where should we start? O or F?
The right-hand side? F?
Right-hand side, that's true. But also, guys, look here on this rule, on the rules again. Who is mentioned before, oxygen or fluorine? So guys, look at these rules that we were talking about and tell me which one came first, which one was mentioned first.
Fluorine.
So fluorine is rule number 4. and oxygen is rule number 5. So when you're actually going with these rules, you can actually go in the order. So whichever one is given first, I mean, in this rule, that has a higher priority. Okay, so that's what you should assign first. All right. Okay, so guys, let's go back to OF2. So yes, fluorine is on the right-hand side. So you start with the right-hand side, that's fine. But even if it was on the left-hand side, we'll still have to start with fluorine because the rule for fluorine has a higher priority than oxygen. Okay. So always look at that rule for assigning oxidation state just to be safe every time. Right? Okay. So now guys, if you guys are starting with fluorine, what should we do first? Fluorine gets what charge?
-1.
-1.
-1. We know that from periodic table. So -1 times 2 is?
-2.
-2. This makes oxygen how much?
+2.
Positive 2. Now guys, what's the answers here? Oxygen gets what number?
+2.
+2.
+2. And fluorine gets what number?
-1.
-1. So guys, what do you see weird here?
Oxygen's +2, which
Oxygen
is
is
weird.
+2. We never thought that we're going to be assigning oxygen a positive charge. Remember, we learned from beginning oxygen is -2, -2, -2. This is where I wanted to mention that oxidation number or oxidation state is not the same thing as ionic charge. Yes, they are very closely related. The oxidation state has been the numbers has been taken from the ionic charge from the periodic table, but they don't mean the same thing anymore. Okay, so oxygen +2 here is just indicating that this is less stronger than fluorine. That's what it's indicating.
Less strong in, like, what's the point of
Strong in the term.
oxidation state?
So
Like, why would you, yeah.
right, it's that arrow thing, remember? If
Oh,
I
okay.
OF, who is stronger, O or F? So oxygen is 3.5 and
Mhm.
fluorine is 4. Who is stronger?
Fluorine.
Fluorine is stronger. So you see my arrow goes this way. So this becomes partially negative and this becomes partially positive. You see my oxygen is sitting on partially positive. That's what we are seeing here, positive.
Mm.
Okay. All right. Now the number being +2 again does not mean anything here. It just means that we're just trying to make them follow what the periodic table says. The significance here is only the positive and the negative. That is what is actually significant. Now, if you look at CO, guys, carbon was 2.5 and oxygen was 3.5, and we made the arrow towards oxygen, and oxygen was partially negative and carbon was partially positive. So if you see in this example, oxygen is partially negative. In this example, oxygen is partially positive. What does that indicate? That just indicates that these charges, oxidation number, oxidation charge, is relative. Okay,
Mm.
like oxygen can be negative or positive depending on what it's sitting with.
Mm.
Okay, right.
So it's really just like electronegativity comparison between whatever you have in that compound and giving a number for that, I guess.
Giving them a number, yes, and those numbers look similar to the ionic charges, but they don't mean the same thing. Okay, a +2, the oxygen here +2 in OF2 example does not mean it lost 2 electrons. No, it did not, because it's a covalent bond. It's a covalent molecule. Okay. Right. Questions, guys? No. Okay. Now let's finish these rules. So we talked about oxygen. Now these ones you already know, guys. Group 7, which is fluorine, chlorine, bromine, iodine. What charge do they have?
-1.
-1. And then fluorine has already been mentioned before. Okay, so don't mix that fluorine in this group 7A. Fluorine was exceptionally mentioned in rule number 4, so it always has the higher priority, even before oxygen. Okay. And then group 6, guys, is -2, like sulfur or oxygen. And then group 5 is -3, like phosphorus. Okay. Now, these rules you already knew. This rule you already knew. Okay. And then this part for oxygen you already knew. So you want to read this again just to make sure you understand this whole thing. Okay. Now, the last part here, this again, you know this pretty well. The oxidation state word is used interchangeably with oxidation number. So we just mentioned that oxidation number, oxidation state is the same thing. and then they indicate the charge on the single atom ions. It's always per atom. And then guys, look here. What does iron parentheses 3 actually mean? That +3 is the charge for Fe. So it's just mentioning that here again, which you know is Fe3 plus. It's written as iron, iron 3. You all knew that already from nomenclature. Okay. Right. Questions here, guys?
No.
No? Okay. Now, guys, let's look at the redox reactions themselves. So redox reaction. So guys, redox reaction, basically, what do you think, guys, the word redox comes from?
Reduction, oxidation.
Reduction and oxidation. So if you combine these two words, you make redox. And guys, why they're combined is because redox or reduction and oxidation take place at the same time. It's never possible for only reduction or only oxidation to happen in a reaction. Both have to happen at the same time. Okay. Now, let me give you guys an example of a redox reaction, and let's see what actually happens here. So guys, if you combine sodium, you see when I say sodium, I'm talking about sodium metal, which is just Na. And then I'm talking about chlorine. So guys, when I'm saying that sodium reacts with chlorine, what do you think I should write for chlorine? Like what should I write? Should I write Cl? Should I write Cl2? What should I write here?
Cl.
So I'm talking about they're in their elemental form, in their natural form.
Oh,
So
Cl2.
Cl2. So sodium in natural form is sodium, and chlorine is Cl2. When they combine, they make NaCl. Okay. This reaction, of course, is not balanced, and that's not the point for doing this. So it's okay if it's not balanced. Okay, we'll balance it later. The point is that you guys want to tell me what are their charges on left-hand side and right-hand side. We're going to compare their charges, okay? So tell me, what is the charge of sodium here?
+1. No, 0.
It's 0. So remember, like when we were learning, if I ask you this sodium has what charge or oxidation state, it's simply 0 because it's in its elemental form. Okay. And guys, this chlorine is what charge?
0.
0. So let me write that here. Now tell me, in NaCl, what is the charge of sodium?
+1.
+1. And what is the charge of Cl?
-1.
-1. So we understand what we're doing here, guys? When it's a compound, we are figuring out the charge from periodic table. But when it's in the element form, they don't have any charge unless mentioned. Okay? All right, now.
And this rule only applies for oxidation, right? Like the oxidation states?
Yes, this is for oxidation states. Yeah, even for the charge, it's the same thing. Like here, actually, you see this reaction is actually making ionic compound. So you can actually use the term ionic charge here. So guys, just to keep it simple, in your head, you should understand that for covalent compound, we should not be using the term charge. We should be using the term oxidation number or oxidation state. But on the exam, oxidation number, oxidation state, charge, they all mean the same thing. Okay, it's the same way to find them. That's still the rules for finding the charge or oxidation state are the same. Okay, they might mean something else, but they actually, the way to find them is the same. Right? So now if we compare left to the right, sodium went from 0 charge to +1. Everyone see that? It went from +0 to +1. And what happened to chlorine, guys? It went from 0 to
-1.
-1. Do you notice one of them's number went up and the other one's number went down? Okay. Now, can you guys describe me what is actually happening here? Who is gaining, who is losing the electron?
Sodium lost and chlorine gained.
Exactly. Sodium, who had a charge of 0, became +1, meaning it lost 1 electron. And guys, who gained that electron then?
Chlorine.
Chlorine gained that electron. That's why it went from 0 to -1. Does that make sense, everyone? Okay, now, when we are writing these charges, guys, and again, you're going to see questions on this on your exam where you'll be identifying who got oxidized and reduced. So look at this part carefully, okay? You see chlorine went from 0 to -1. What happened to the number? Did the number increase or did it reduce?
Reduce.
Reduce, guys. Just by remembering this term, that when the number reduces from 0 to -1, when number reduces, or a chlorine got reduced. It's as simple as that, guys. Okay. So chlorine got reduced, and it literally got reduced, went from 0 to -1. Okay. Now sodium, who went from 0 to +1, what does that got? Did that got oxidized or reduced? So it's just the opposite. It got oxidized. Yes, it got oxidized. Okay. So one is getting reduced, the other one is getting oxidized, and they both have to happen at the same time. That's why these reactions are called redox reactions. Okay. Now, the one who is this part, guys, the reduced part, we can call that this is the reduction half, and one where it got oxidized, that is the oxidation half. Okay, so sodium going from sodium 0 to sodium +1 is the oxidation half, and then Cl2 going from 0 to -1 in NaCl, that's a reduction half. Okay. Now, one more thing, guys. What does this oxidation and reduction mean by definition? What do they mean? Oxidation and reduction. We need to know these in terms of the electrons. So electrons in one of case got, you lost electron, one of them gained electron. So guys, in reduction, what do you think happens? You gain or lose electron?
Gain.
So reduction, chlorine went from 0 to -1, so it must have gained the electron. So that's what you say here. Reduction is you gained electrons, or electrons gained. Okay, and oxidation must be then electrons
Lost.
lost. Okay, great. Any questions, guys, so far? Guys, what if we simply have to balance this reaction? What do we do?
2 NaCl.
So it should be 2 NaCl, and then you go back here and
2
put it
Na.
here, and that's balance, right? Okay. Now, remember, guys, you should never be confused with these numbers in the front with the oxidation state. These numbers, NaCl being Na being +1, Cl being -1, is not affected by these coefficients in the front. So always ignore them when you're finding the charge or oxidation state. Okay. All right. Questions so far, guys? Now, one more thing to learn. You see, guys, sodium got oxidized itself. So sodium itself went from 0 to +1. So it oxidized itself, but you see that sodium is responsible for reducing somebody else? You guys see that here? Sodium itself is getting oxidized from sodium 0 to sodium +1. When it's getting oxidized, it's responsible for reducing chlorine, and vice versa is also true. Chlorine, who itself is getting reduced, is responsible for oxidizing sodium. Does that make sense, guys? Okay, so the one who is getting oxidized is responsible for reducing somebody else, so it is also called reducing agent. Okay. Now, the one who is getting reduced, what do you think that should be called? What agent?
Oxidizing agent.
Oxidizing agent, okay? So guys, always remember they're always the exact opposite, okay? The one who is getting oxidized is the reducing agent. The one who is getting reduced is the oxidizing agent. All right, questions here? Okay, so guys, on your exam, you should expect a question like this. And again, work on the multiple choice worksheets that I've posted. You're gonna see questions similar to this, okay? On who is getting oxidized, who is getting reduced, who is the oxidizing agent, who is the reducing agent. Now guys, I want to talk about our next topic, which is related to redox, but it's called balancing redox equations. Now for this, guys, you have to be extremely focused on what I'm going to be talking about here. So this is a long reaction, guys. What we'll do is we'll start with one reaction. We'll have to balance that reaction just like we balance the other reactions. Like when we balance our single displacement or double displacement or combination reactions or combustion reactions, those were pretty simple. where you just balance the number of atoms on both the sides. When it comes to redox, they go one step ahead. You have to balance the charges as well. And for that, guys, you need to be following some set of rules. Okay, so pay attention here and then get ready to take some notes. We're going to be working on one problem. And as we work on that problem, we will be talking about the rules as well. Okay.
Omar,
Yeah.
are we going to be doing both acids and bases?
Yes.
Okay.
So let me write down the reaction here. MnO4 -1 plus Cl -1 producing chlorine and manganese +2. Okay. Okay, so this is our reaction, and you are gonna find a couple of questions like this on your exam, maybe one question on this on your exam, and then you're also gonna see on your the 3 quizzes that I've posted this week. The last quiz is on this topic where you're gonna be balancing the redox reaction. Okay. So guys, what we're doing here is we're gonna do is we're gonna be our first step is we're gonna split our reaction into 2 halves. Okay. Now, what do we mean by 2 halves here? So guys, by 2 halves, we mean this. We are going to split this reaction into 2 halves, meaning we're gonna pair up similar molecules on one side. Let's see, what does that mean? You see MnO4 on the left-hand side, what did it become, guys, on the right-hand side? So look for the common ion that you see on the right-hand side, or a common molecule that atom you see on the right-hand side.
Mn+2.
It became Mn+2. Okay, that's our 1/2. And our second half is we're Cl negative, so I'm picking the Cl negative. It changed to what, guys?
Cl2.
Cl2. Does this very first step make sense, guys? What we did is we just picked the similar molecules or atoms or ions, and we split them to 2 halves. Okay? So this is basically actually called half reaction method, guys. Half reaction method. Now, guys, the very first step, so, I mean, first step after splitting is our second, so let me call it a second step. So your second step is to balance non-hydrogen oxygen atoms. Okay. So guys, look here in this reaction, MnO4 -1, making Mn+2. What is the non-hydrogen oxygen atom here, guys? It's this manganese. Okay. You see oxygen, we're ignoring that for right now. So we first focus on manganese. So guys, is the manganese balanced right now? And we're just worried about the number of atoms.
Yeah.
Yeah.
Yes. You see we have 1 manganese here and we have 1 manganese here. So that step is sorted. Okay. So we'll see later on how this one is not and how we'll fix that. Okay. Now our third step. So for manganese part, there's no need to take care of this non-hydrogen oxygen atom step. So we're going to skip that step for right now. And you're going to go to our third step, which is to balance oxygen by adding H2O. Okay. Now guys, look at that reaction again. MnO4 -1 giving you manganese +2. Guys, how many oxygens do you have on the left-hand side?
4.
On the left-hand side, we have 4. On the right-hand side, how many do we have?
0.
We have none, right? We have no oxygen. So do you think there's any way to balance this without adding something else? No, right? There's no oxygen on the right-hand side. So there's no coefficient. There's no there's no formula on the right-hand side for oxygen where you'll put the coefficient in the front and change the number of oxygens. So because of that, this is where water comes in, okay? So guys, I'm going to rewrite the equation. So when you see MnO4 -1 becoming Mn plus 2, we actually need to add the water. So guys, we have to add the water on the right-hand side. Does that make sense, guys? Why we're adding to the right-hand side?
Yeah,
Because
it's a balance.
left-hand side, we have 4 oxygens. Right-hand side, we had no oxygens. So we are putting in water. Now, guys, tell me how many waters should we add?
4.
We should add 4 waters. Why are we adding 4? Because this gives me 4 oxygens, right? That's what we wanted. We have 4 oxygens here, left-hand side.
We don't care about the H that we added in.
We do. That's our next step. So our step number 4 is to balance hydrogen by adding H plus. Guys, I do not want you to forget this, that it's H plus and not just H. It's very common that you will forget that it has a positive charge. Okay, it's H plus that you add. Now, I'm going to rewrite that reaction again. MnO4 negative becoming Mn plus 2 plus 4 waters. Now, guys, tell me, which way should I add H plus? On the left-hand side or right-hand side?
Left.
On the left, because right-hand side already has hydrogen. Now, tell me, guys, if I'm adding H plus, how many H plus should I add on the left-hand side?
8. 8.
8, because you have 4 times 2, 8 hydrogens here. So you need to add 8 H plus. All right, guys, are we good so far?
Mm-hmm.
Okay. Now, what's our next step? Our next step is to balance the charge by adding electrons. Okay. Okay, so let's look at this one. Okay, so tell me here, when you look at this reaction here, what we need to do is we need to balance the charge on both the sides. So tell me, right-hand side has how much charge?
+2.
Yes. So you see, this manganese has a +2 charge, and water has how much charge, guys?
0.
It has no charge, 0 charge. So see, your right-hand side is +2. Guys, please make sure you guys are listening to me here. This is a very important step. So right-hand side has 0 charge on water and +2 on this manganese. So you put +2 here. That's my charge on the right-hand side. And then now I'm going to look at the left-hand side. Because MnO4 has how much charge?
-1.
It's -1. And what is the charge here?
Is it +8?
+8.
Yes, it's +8. Yes. So guys, you see H is +1, and there are 8 of them. So guys, this is +8 charge. Does that make sense for everyone that this is +8?
Yeah.
Okay.
Yeah.
If this is +8 and this is -1, how much is the charge on the left-hand side?
+7.
+7, exactly. Does everyone get that?
Mm-hmm.
Okay. Now, if this is +7 and +2, guys, tell me, we know that we're going to balance the charge by adding electrons. Tell me, what is the charge of electrons? That's positive or negative? It's
-1.
right? It's -1. So which side do you add the electrons, guys? You're going to add that here. You balance the charge by adding electrons, and you add the electrons to the more positive side. This is a very important step, that you add it to the more positive side so that the charge become equal on both the sides, okay? Now, one side is +2, one side is +7. Just tell me, which side should we add the electrons, left-hand side or right-hand side?
Left.
Left.
Left, because it's more positive, right? Now, tell me, if I want to make this +7 a +2, which is equal to the right-hand side, how many electrons should I add? Plus how many
5.
electrons?
5.
5 electrons, okay? This will change this +7 to a +2, which will be equal to +2 on the right-hand side. Again, guys, look on the screen. Our goal was to make this charge equal on both the sides. Our goal was not to make them 0. Okay? Right, now, now I'm gonna erase this, the charges.
I have a question. How come we're just allowed to add H plus in water? I'm just wondering.
Okay, so see, all the reactions are happening in water. So water is just roaming around, and we can just borrow that water because all the reactions happen in water, all the redox
Oh.
reactions. Okay, now,
Oh, okay.
okay, so we are adding H plus because at the end when this reaction is done, I'm going to tell you that this reaction is happening in acidic condition. And acidic condition means there are lots of H plus sitting around. Okay? And we also going to learn how to change it into a basic condition, in a basic solution. Okay.
Okay.
Right now. So does this part make sense, guys? How we balance this first reaction, the first half? So now the number of atoms
I
are
have a
good,
question.
and the charges are also good. Yeah, question, Jason?
How did you exactly add the 5 electrons?
electrons?
Where did they come from?
Sure, let's see. So first we need to find out the charge. Tell me what is the charge on the right-hand side of the reaction?
It's +2.
Positive. On the left-hand side is how much?
It's +7.
Positive 7. So the rule says that in order to make these charges equal, you can add electrons because this is a redox reaction. In a redox reaction, the exchange of electrons is taking place. So to balance the charge, anything that has charge in a reaction is basically electrons. So you use electrons to balance the charge. And the goal is to make the charges equal. See, if this is +2 and this is +7, which side should I add electrons? You add it to the more positive side. So you add it to the +7 side. In order for this +7 to become +2, how many negatives should I add to this?
I get that it's 5, but where did those 5 come from?
What do you mean 5 electrons come from?
Yeah.
They're coming from nowhere. This is all theoretical. You'll see in the
Oh,
very
okay.
next step. You'll see in the very next step. You'll see in the very next step where that electron goes, okay?
Oh, okay.
Question? But you're going to see what happens in the next step, what happens to those electrons. Okay? All right. Now, so far, we have this 1/2 sorted. Now, we're going to go back to our second, remember the second half, which we did not touch yet?
Mm-hmm.
You're going to apply the same rules here. So what was the very first step, guys? I mean, the second step after you split?
To balance the atoms that aren't oxygen and hydrogen.
Right, so you balance the non-oxygen hydrogen atoms. We don't have oxygen and hydrogen here. The only thing we have is chlorine. So how do you balance this chlorine, guys?
2 on the left is a coefficient.
So you just put a 2 here in the left, right? Once you put a 2, that's 2 chlorine, 2 chlorines. So that's good, right? Now, what is the next step after that, guys? So you balance the non-oxygen hydrogen, we did that. Is there a need to add water?
No.
There's no oxygen, so you skip that step. The H plus step, you skip that, right? What was the next step after that? After fourth step, what was
balance the charge?
Yes, to balance the charge. Now, for charge, guys, find out the charge. What's the charge on left and right?
-2.
-2 on the left-hand side, and right-hand side is?
0.
0. Okay. So now, guys, which side should we add the electrons?
The right-hand side.
The right, which is more positive, right? -2 versus 0. 0 is more positive than -2. So how many electrons should I add here?
2.
2. So this will turn the 0 into a -2, and this -2 then matches with this -2. Okay, everyone understand what we're doing here?
Yep.
Okay, all right.
That was way easier.
I know,
Yeah,
right?
this side was way easier, right? Exactly. So this side had nothing else. It had no water, no oxygen, so that we skipped all those steps. Okay. Now, this is again a checkpoint, and by checkpoint, guys, look at this carefully. I'm going to ask you one question here. Which side do you see the electron on this half? Which side do you see the electron of the arrow? Left or right hand side of the arrow?
Right.
Right.
Right hand side. For this reaction, which side do you see the electron? On the left hand side or right hand side of the arrow?
Left hand.
On the left hand side. Guys, this should be your checkpoint. Your electrons must end up on the opposite ends. If they're on the same side, you've done something wrong, and you should go and check your problem again. Okay. So,
I have a question.
yeah.
Is it just a coincidence that the right-hand side Mn plus 2, and then on the left-hand side it's -2 Cl for that? Is that just like a coincidence?
It's not. So it's not a coincidence because this reaction is pretty simple. We can actually notice that here that this manganese, this chlorine which is 2Cl minus, which is 2 negative charges. And then see, when we're going to get to the end of the reaction, you will see actually what happened. We'll go over that, okay? But for right now, this being -2 and this being +2, no, they're not the exact same thing, because manganese charge here is something else. Okay, you can see here manganese is what charge. Can we tell, guys? Again, this is this is not the part of this problem. I'm just asking you guys. MnO4 -1. What's the charge of manganese? Oxygen is -2 times 4 -8. So this side will be
7? No, no.
+7. Right.
Yeah.
So it went from +7 to +2. So it has basically gained 5 electrons. That's what has happened. Okay. It's not just that 2Cl negative electrons, not just 2 electrons, but 5 instead. Because we also have that H plus becoming water on right hand side. That H plus is also giving electrons to MnO4 negative, or actually gaining electrons from MnO4 negative or Cl negative. Okay. So yeah, we cannot just simply look at those and tell that is it the same number of electrons. No, it's not. Okay. All right. So now, guys, let's look at these two reactions. Let's look at our 6th step. Let me rewrite that equation here so that we have them at the same level. CO2 and 2 electrons. Okay. Now, our 6th step, guys, is we have to bring these two reactions back. So add the 2 halves. So our first step was to split them. Our 6th step is to bring them back. Okay. Now, look here, guys, on the screen, and let's see how you want to add them. So you see the left-hand side of this reaction? We're going to add it to the left-hand side of this reaction. And then look at the right-hand side of this reaction. We're going to add it to the right-hand side of this reaction. Does that make sense, guys? So the left side is being added together, and the right-hand side is being added together. Now, for these questions, for redox problems, guys, the key is that you're patient with these and not being lazy. So rewrite the equations, okay? Do not just trust your memory here. You must rewrite them. So MnO4 negative. Oh, sorry, guys. Sorry. I forgot one step. Sorry. Let's go back, guys. Let's go back. So I'm going to erase this part. So erase. This is not step number 6. This is going to be step number 7. Our step number 6 is to make number of electrons same on both the reactions. Okay. Now, what does that mean? You see, for this reaction on the right-hand side, we have 2 electrons, and the one on the left-hand side, we have 5 electrons. Our goal later on is to cancel these electrons. For that, these numbers must be equal. So guys, tell me, what should I multiply this reaction by, and what should I multiply this reaction by, so that this 2 electrons and 5 electrons will become equal eventually? Multiply the left by 2 and the right by 5? Right. So we're going to be multiplying this reaction by 2, and we're going to be multiplying this reaction by 5. Okay? So guys, let's rewrite the equation, okay? After we multiply, so guys, so guys, don't write here right now. Just tell me, what should I write down? So 2 times 5 is how much? 10 electrons, plus 2 times 8 is 16H plus, and then 2 MnO4 minus, giving me 2 Mn plus 2, and 2 times 4, 8 H2O. Because right now we're not adding the reactions together. We're just multiplying them with the numbers that we wanted to. And then you're going to do the right-hand side. 5 times 2 is 10 Cl minus, giving us 5 Cl2, and then 5 times 2, 10 electrons. Okay. Yes, let me know if you have any questions here. No? All right. Now, guys, tell me for step number 7. What was step number 7? You add the 2 halves back. Yes. So you're going to add them back. And this you guys already know. What should we do here, guys? So now you guys tell me what should I write here. So you're adding the left-hand side to the left-hand side.
Does it matter the order at all,
No, the order
or
doesn't matter. No. Just put them in any order. But the left hand side should stay on left hand side.
10 electrons
10
plus
electrons,
16 hydrogen plus
16
2
hydrogen
Mn
plus 2
2
MnO4 negative
Mn plus 10 Cl minus.
plus 10 Cl minus. Okay. Does everyone get that, guys?
Where did the
Adding
10
up.
electrons come from?
It came from, you see these 5 electrons?
Yes.
This 5 was times by 2,
Okay.
right? Because we wanted the electrons to match on both the sides. Because right hand side had 2 electrons, we're multiplying this side by 5. And this one was 5 electrons, so we're multiplying it by 2 so that we get 10 electrons on both the sides.
Okay. Thank you.
Yeah. Right. So now, what do we do on the right hand side, guys? So you tell me what should I write on the right hand side?
You should get 2 Mn plus 2 plus 8 H2O
Great.
plus 5 chlorines
Chlorines.
plus 10 electrons.
So 10 electrons. Okay. Now, guys, once we're at this point, what do you guys think we should be doing next?
Reduce.
Yeah, so we're going to be canceling as many molecules, atoms we can, but the only things that you can cancel, they should be exact same. So it's not that you can take these 16 H plus and cancel these 16 H2O hydrogens. Okay, you cannot do that. They must be identical. Okay, now
You can cancel electrons.
Yes. That was the whole point of doing this, right? The whole point of doing this last step and the step before that was so that our electrons cancel. If your electrons don't cancel, guys, what does that mean? We have done something wrong. You must go back and check your problem again. Okay. Now, do you see anything else that cancels? No, right? Nothing else cancels. So now we're just going to rewrite this equation, 16.
Good question.
Yes.
Oh, never mind. I was gonna say if that was 5Cl and not Cl2, can you cancel out some of them?
Yes.
If
So yes, we're gonna actually when you're gonna do the couple of steps after later, then we're gonna actually see when when they will become same. So yes, if this was 10 Cl minus and this was 5 Cl minus, we can get rid of all 5 Cl minus from here, and this 10 Cl minus will become 5 Cl minus. Yes, we can do that.
Okay, thank you.
So 16H plus 2 MnO4 negative plus 10 Cl negative, giving me 2 Mn plus 2 plus 8 H2O plus 5 chlorines. So this is what we got, right? Now, guys, just to confirm, can you guys see if this reaction is balanced? Because at this point, everything should be balanced.
2 Mn, 5 chlorines, 16. Yeah.
You see, this is 16H
Yeah,
and 16H.
balanced.
Then we have 2 Mn, and then we have 2 Mn. And then we have 2 times 4, 8 oxygens. We have 8 oxygens, 10 Cls, 10 Cls. And does the charge, is the charge same? Because that also matters there. This is plus 16. How much is this, guys?
Minus 2,
This is minus 2, and this is how much?
minus 10.
Yes, so minus 10 and minus 2 is minus 12, and this is plus 16. So what's the charge on this side?
Plus 4?
Plus 4, right? What's the charge on the right side?
Plus 4?
Plus 4.
Plus 4. And you see that matches 2? So it's not just the number of atoms that are matching, but the charge also matches. So this is why this is called a balancing redox equation, where you balance the charge and the number of atoms. That's what it's doing here. Okay?
Can you zoom out a little bit so I can screenshot the final product? Thank you.
The whole thing, or is that good?
No, that's good. That's good.
Okay. All right. Now, once we are at this point, do you guys note? Okay, first of all, there was a question earlier that where did the electrons come from? Do you see electrons came from nowhere, and we don't have those electrons anymore? We just played with the electrons so that we balance the charge. At the end, we get rid of the electrons because in an equation, you can never show electrons. So remember this, guys, that electrons can never be sitting in a solution. A free electron can never be found in a solution. They are transferred from one atom to the other, so we should never show electrons in our balance equation. Okay, so the whole point of playing with the electrons was to balance the charge. Once we balance the charge, you saw how we got rid of the electrons in our reaction. Okay. All right, now you guys notice that this reaction has H pluses. This makes the solution acidic or basic, guys? If you remember about acid,
Acidic.
acidic. So if a solution, so guys, look here. If a solution has lots of H plus in it, that solution is considered acidic. If the solution has lots of OH negative hydroxide ion, then that solution is considered what?
Basic.
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 If I have equal amounts of H plus and OH minus, what is that called?
Neutral.
That's neutral. That's neutral, right? So what does this reaction look like to you?
Neutral? No, acidic, because that's more H plus, right?
Yes, so ignore the H2O. H2O is not doing anything. You see here we have lots of H plus, so that matches this condition, acidic condition. So the question, there will be two types of questions, guys. One will say that balance the reaction in the acidic solution, and one question will say balance the reaction in basic solution. So what have you done so far, guys? We have balanced it in which condition?
Acidic.
In acidic condition. Now, the questions might also ask you, balance this in basic solution. For basic solution, you're gonna follow the same steps we have done so far. It just needs 2 extra steps later on. And let's learn those steps ahead. So this was acidic condition. We are done with, if the question says acidic conditions, you're done with the question. If the question says basic, you have to add some steps. So let's call this step number 8. So so step number 7, let me actually add 2 halves and cancel common atoms or ions or molecules. So let's just add that under same rule. Again, guys, rule number doesn't matter. Just remember them in the order. Now, step number 8 is for basic solutions. What you have to do here is you need to add OH negative on both the sides. So guys, what are we doing here is we're trying to transform this acidic reaction into a basic reaction. For that, what we do is we take our same reaction, we add OH minus on both the sides. Now guys, let me show you one reaction, okay? Don't copy that right now. This is not the part of the question. Just don't copy this here, otherwise it will confuse you. So guys, if I take this H plus and I combine this with OH minus, so if I take H plus, which is called proton, and I combine with OH minus, which is called hydroxide, what do you think we make when we combine them?
Water.
We make water, right? HOH, which is also called water. So guys, 1H plus needs 1 OH minus, and that makes how many waters? So guys,
Just
1H
one,
plus,
right?
1.
yes. So 1H plus and 1 OH minus makes 1H2O. That makes sense, right? So here we have 16H plus. If I want to get rid of all these 16 protons, how many OH minus should I add?
16.
16, okay? So what we'll do is we'll add 16 OH minus on this side. Now guys, can I just add it on one left-hand side and not on the right-hand side? See, if I just add it on the left-hand side, then I just imbalance the whole equation that I took so long to balance it, right? So you must add 16 OH minus on both the sides. So guys, what was the step? The step was to add OH minus on both the sides. And guys, who decides how many OH minus you add?
Side with the H plus.
How many H plus you got, right? So now guys, let's rewrite this equation, okay? So 16, so guys tell me 16 H plus and 16 OH minus will combine to make what?
16 H2O or
16
HOH.
H2O, right, or HOH. So plus 2 MnO4. So I'm just rewriting the whole equation, but I just combined that 16 H plus and OH minus to make 16 waters. On the right hand side, everything is as it is. 8 waters, 5 chlorines, and then we remember we added 16 OH minus. Okay, so we have added 16 OH minus on both the sides. Okay, does this make sense, guys, so far?
Yes.
Okay, did you see we got rid of H plus from that reaction? And now, do you see what do we have now? Does this reaction look acidic or basic to you guys?
Basic.
Basic.
Basic. What makes it basic?
The OH at the end.
The 16 OH minus at the end. That's what is making the solution basic. Now, do you see if we have formed something new that can be canceled?
So in this case, the water.
The water, yes. So guys, your 8th step, which was that you add OH minus on both the sides, you can call it a 9th step or not, or just make sure that you cancel water if you made any water, because every time you're going to add OH minus to H plus, you're going to make water, and most probably there's going to be water on the other side. Okay, so don't forget.
Can you ever start with basic solution and then go to acidic? Is it the same?
No, you always start with the acidic.
So does that mean OH is always going to be on the right hand side, and then H plus will always be on the left?
No, that's not mandatory. No, because maybe you see here why H plus was on the left hand side because we added water on the right hand side. So if this H plus, if we had oxygen on the right hand side, we would have added H2O on the left hand side and then H plus on the right hand side. So the side doesn't matter. It could be on any one of the sides. Did that make any sense? What directed us to have H plus on the left? Because we added water on the right hand side. Why did we add water on the right hand side? Because we had oxygen on the left hand side. So if this oxygen was on the right hand side, everything will be flipped. Okay.
Oh, when we take away the water, like you said, to reduce it, would
Right.
it be the 8 H2O and then the 8 H2O on the side would be gone?
Right. So this all 8 will be gone, and this 16 will be left with 8. So now you again rewrite the equation: 8 waters, 2 MnO4 negative, plus 10 Cl minus gives you 2 Mn plus 2, plus that water is gone, so 5 Cl2, and then you have your 16 OH negative. Okay. Right. Questions, guys? So guys, this solution is now what? This is basic because of that OH minus. So if the question said basic solution, do all the acidic steps and then add those 2 steps at the end to make it basic. So guys, which one do you think I'm going to expect you on the exam?
Both.
Both.
Most probably it's going to be basic, guys. If I had to ask you one question, it will be basic, because in basic you're doing acidic anyways, and then you add extra steps to do basic. So if I had to test you on one question on the exam, it will be basic. Okay. Right. Questions?
Is it okay if you do another example of it?
So for the full thing, I probably won't be able to do won't be able to finish it. Okay. So
okay.
What I'll do is I'll put out this worksheet along with the key for this, and then you guys work on that. Okay. So I'm going to post a few questions, and also when you're going to look at the key for, the multiple choice worksheet, you can actually find a worksheet which has questions like this. Okay, so you're going to work on that. Again, a problem like this does take a lot. So let me do one thing. Let's talk about the lab, and then those who are going to be interested will stay, and then we'll do one more problem. Okay.
Okay.
All right. So now, guys, let me talk about the lab. So we already talked about the lab, but what I did is, guys, I edited this lab so that you guys have a little more detail on how you're gonna finish the lab report. So you guys already did the pre-lab. That's great. and then you guys did the tables and all of that stuff. I made a reference table here. So if you have this reference table, that's great. I think you already made this. If it's in a different orientation, that's totally fine. But this is the information that we need. That's all. But it could be shown like this or in a different way. So I organized this more in steps. So again, you have your data here. Now, when you're doing your data analysis, guys, for this lab, it mentions you what you exactly need to do. I already mentioned that last time as well. So you're going to be using the Excel, and then you're going to be making the standard data graph, and then you're going to be using the graph. You're going to show the trend line, and then on the trend line, you're going to be showing the R-square value and the equation, and then you're going to be showing these calculations. Then you're going to be answering the post-lab questions. And at the end, guys, I've mentioned exactly what you need to do for lab writing, a lab report. So you already did the pre-lab, so you already are done with this first step. Then you have your table for dilution, which I believe you guys already did. And then you have your table for absorption. This is a table which is given to you. And then after this, guys, you will make the graph. Then you're going to attach it on your in your lab report that you're going to turn in. And then you are going to show all the calculations. And guys, calculations are shown here. So this is actually showing you exactly how you get to the percentage of the copper. And I think I discussed this last time as well, but this is summarized again for you. Okay. And then you're going to be doing your discussion and conclusion. Then you do your post-lab questions, take a photo from your lab notebook, and then you submit it online as one PDF document. Okay. And guys, this lab is now going to be due in a week from today.
So we're not typing this out?
No, you don't type this out, just do it in the lab report, and that should be good enough. Okay.
What if
Then
we already started typing it? Can we leave it typed?
you can leave, yeah, if you already did, then yes, you can leave it typed.
I think it says that this lab is due on Wednesday or something like that.
Yeah,
This Wednesday?
yeah.
I'll change it to, I think it was the other lab, the pre-lab for, I'll
They're
change
both
it if
due
it's,
on
so, so this is your, let's go to lab submissions. So April 15th. Did you guys already, I said last time, what date did I say last time? Did I not say a Monday from, a week from when we finish it today?
Yeah.
Yeah, so let me change this. So from, instead of April 15th, it's going to be 20th, okay? All right. Now, but this Wednesday, guys, you're going to have the pre-lab due, okay? So for lab number 5, since we only get 2 days, this Wednesday and the Monday, I want you guys to work on the pre-lab for lab number 5. And for lab number 5, I believe I posted the document. You guys already have lab 5 with you. So let me go here. So for lab 5, which is the chemical reaction lab, before you come in on Wednesday, you guys want to read this lab and write the pre-lab for this. And for the let me show you the lab. I think I linked the lab. Let me see. Okay. All right, so let me link the document directly in here. All right, guys, so this is the next lab that you're going to be working on, which is the chemical reaction and equations. So guys, this is again, it was an interesting lab. If we would have done this on campus, then you would learn how to actually mix chemicals and then see how to make observations. But again, those have been supplemented by some videos that you guys will get to watch. So this lab has pre-lab questions. So you want to answer those pre-lab questions, and then you guys also have the procedure written here. So you'll have to summarize that too. So guys, in your lab notebook, you're going to be writing the pre-lab. You're going to be answering pre-lab questions and then summarizing the procedure. That is what is going to be due on this Wednesday. Okay.
Do you want us to copy the charts?
The chart, yes, you want to copy this chart, and then let me show you.
Does a
So
pre-lab,
this chart is what, yes, yeah, there is a pre-lab. What's that? Is that what you're asking?
does it have to be in our lab notebook, or are we allowed to just type it and like upload it as a PDF?
So you can actually type it in if you want, if you guys find that more, if you find that more useful. I mean, lab notebook was required if you're working in an actual lab, then we need an actual lab notebook. But we also want to see that you guys get the habit of writing in a lab notebook. That's why we are promoting you guys to still keep writing them on the lab notebook. Do you guys prefer writing? What do you guys prefer? Do you guys
Typing is easier because then we can also, like, if we mess up, we can copy and paste, and we don't have to physically rewrite everything.
Right,
Yeah,
well,
I feel
Mostly
like
for
I've
like the
wasted
tables and stuff.
what's that?
For the tables, it makes it a lot easier because if you miss
Okay.
like one little thing up on a table in a notebook,
Sure.
it's over.
Okay. Okay. So let's keep it the Word document. Then you guys can type it in on your computer, and then don't use your lab notebook. That's fine. And then but still upload the PDF. Okay. Right. Now, so you're gonna read this lab, guys, and then for the table, after you guys will read the lab, we'll worry about the table on Wednesday. Okay. So just summarize the procedure and answer the pre-lab questions, and then once you will have read the lab, we'll discuss this on Wednesday, and based off that, you guys will make the tables. So ignore the tables for Wednesday. Just summarize the procedure and the pre-lab questions. Okay.
And those are part of the procedure, right? Those tables, or is it?
No. So these are part, but again, ignore the tables. So don't worry about the tables. Okay. So we will discuss the tables because we'll have to modify these tables. This table is good as it is, but for this table, we'll have to add another section where we'll be putting in the data, like what are our observations. Okay. So this, and the procedure is what we will summarize. Okay. And on Wednesday, I'll also tell you there are some reactions that you'll need to write down, like combining these, and you'll be writing down the reactions. So that will be separate, okay? And when it comes to reactions, maybe you're gonna find that actually easier to write on the lab notebook. So we'll discuss that on Wednesday. You have to write the chemical reactions. I think that will be easier to do on a lab notebook instead of typing them in. So we'll talk about that too, because you'll be writing lots of complete ionic, net ionic equations here. So we'll discuss that on Wednesday, okay? All right, now for the lab, guys, the copper concentration lab, do you guys have any questions? Because now we have read this lab, we have discussed this lab before. I'm showing you here what exactly you need to turn in. So you have two tables, and then you have a graph, and then you have all these things mentioned here: calculation, discussion, conclusion. So you guys have any questions on this lab?
There were some post-lab questions that said, like, how come you can't find the concentration of zinc directly using a spectrophotometer or something?
So yes. So the question was that so you see, we were detecting copper in this reaction, but not the zinc in the water, because the washer is made of brass, which has both zinc and copper, but we're only testing copper and not zinc. The reason is, if you ever gonna see the copper, remember the copper solution? What's the color of copper solution, guys?
Blue.
So copper sulfate is a blue solution, or even the this is the copper sulfate pentahydrate, so the powdered form of copper sulfate, even that looks blue. And if you look at zinc sulfate, then zinc sulfate has no color. So it's white in color like this. Okay. So spectrophotometer, guys, how does spectrophotometer works? Spectrophotometer works on the absorption, right? So you see this copper sulfate is giving off blue color, which means it's absorbing some color and not absorbing some other color. So spectrophotometer is good for working with those kind of solutions. If something is clear, then you cannot use spectrophotometer for that stuff because that solution is just absorbing all different kinds of lights. Okay, so zinc, since it's clear, we do not have an absorption curve for zinc, but for copper we do. That's the reason why we work with copper instead of zinc in this case. Okay, right? So you can mention here that since copper sulfate has absorption at a specific wavelength, and zinc does not have any such absorption, high absorption at one wavelength. Okay. All right. Any questions, guys? Any more questions? No? Okay. So guys, this lab is going to do in a week. And then Wednesday, you're going to have your pre-lab due for the next lab. And then again, I posted 3 quizzes and they're going to be due again by next Wednesday, okay? They're all on chapter 4 stuff that we've learned so far. So stoichiometry, and then the redox reactions, and then balancing reactions, okay? Now, let's see if we can do another problem.
Oh, sorry.
Yes.
Can I ask actually a few more lab questions? I had to look at it.
Sure.
Okay, I don't actually know how the cuvette not being wiped clean has to do with the spectrophotometer, or if you don't place it properly, I'm not sure how those affect the spectrophotometer.
Let's see. So let me show you the cuvette and the spectrophotometer. So this is what the cuvette looks like. You see, this is a cuvette.
Mm-hmm.
So first of all, do you notice, let me find a nice clear picture. Yeah, here, let's look at this one. You see in this image, one of the side is blurred, whereas the other side is more clear.
Mm-hmm.
So like one side is grainy, the other one is clear. So let me find actually better images for that. Or for instance, let's take this one for example. You see how our reading, how we're gonna place this cuvette into the spectrophotometer is gonna make a difference. If I, let me see if I can copy this so I can draw. Okay, so you see how this is the clear portion and this is not the clear side. So when we are placing this into a spectrophotometer, so spectrophotometer basically has like a place where we're going to be putting this cuvette in. So we can take this cuvette, and it's important that we wipe down these sides, because if you're going to touch with our fingers, then you see if I touch this with the fingers on this side and I have my fingerprints here, and then I put this into the spectrophotometer, and so let's say the spectrophotometer light is passing through here, then my fingerprints are going to absorb some of the light. So that's why, first of all, it's important that we use a CHEM wipe to clean the cuvette so that we don't have any fingerprints. And again, you can see it's a good idea to actually wear gloves. Even if you're wearing gloves, just to avoid any dust particles, you still need to wipe it down. Okay, that's one thing, that it's important to wipe down the sides so that the light is not absorbed by the fingerprint itself. And the second is that the cuvette, the clear side should be facing the light, not the other side, not this side. So light should be passing through here, not the other way. So it should not go this way, but it should go from left to the right like this. Okay, so the cuvette the clear side must be placed facing the light. Okay, because the clear side the glass has no absorbance. This side has high absorbance. So we do not want any other thing than copper to absorb. We don't want the plastic, the glass, or our fingerprints to absorb any light. Okay, does that answer your question?
Yes, it does. Thank you.
Okay. Right, any more questions, guys? No questions? Okay. Okay, so let's do another problem as, let's see, let's pick one of the problems here. Okay, so let's take this one. So H2S plus NO3 minus, H2S plus NO3 minus, producing NO and S. Now, so guys, again, we're going to be trying to balance this equation. And you guys tell me what are our steps.
Step one, we got to split them up, right?
So when we split this up, how should we split this up?
So we'll have like H2S, and then on the other side of the arrow, the S, sulfur.
Right, and then we should pick
NO3 negative, and it turns into NO.
NO, right? So we're going to be, again, just similar things. You're going to pick them together and place them with each other. Okay, now, so this was our first step, split into halves. What's our next step?
Balance.
Right, so what do we balance first? Oxygen, hydrogen, or non-oxygen hydrogen?
Non-oxygen hydrogen.
Non-oxygen hydrogen. So in this case, what do we balance first on left-hand side?
It would be sulfur, but
It would be sulfur.
there's
but
nothing. It's already balanced.
It's already balanced. Sulfur, H2S has one sulfur, S has one sulfur, so that's already good. And then what's next? We need to balance what?
We
See,
balance.
right.
Shoot, I forget. We're supposed to do
We're
oxygen.
supposed to do
right? There's
oxygen,
no oxygen.
and there's no oxygen. But we do have hydrogen, right? So
Yes.
it's non-oxygen hydrogen first, then it's oxygen, and then it's hydrogen.
And we use H plus, right, to balance it.
Right. To balance hydrogen, we add H plus. So here we have two hydrogens. This side we should add. What happened here? What happened here? Just give me a second, guys. Something happened to my pen. Let me restart this. Okay, so guys, we got sulfur, and then we add how many H plus?
2.
We add H plus. Right. Now, what's the next step after we balance our hydrogens?
Balance the charge.
With the charge, this side is 0 charge, and this side is how much?
+2.
+2. So where should we add electrons? Left or right?
To the right side.
To the right side. How many electrons?
2.
2 electrons. Again, guys, why are we adding 2 electrons? Because that will make the charge 0, and 0 will be same on both the sides. Again, guys, was the goal to make this charge 0, or was the goal to make them equal?
Equal.
The goal was to make them equal. Here, just by a chance, that happens to be 0, okay? So never, don't worry that you have to make the charge 0. No, you have to make the charge equal. Here, by accident, it's 0. Okay. All right, questions, guys, here so far? Okay, now we're done with the left-hand side. Now let's look at the right-hand side, guys. For right-hand side, we are looking at NO3 and NO. What should we balance first?
The non-oxygen and non-hydrogen.
Right, which should be nitrogen, which is already good. There's one nitrogen, one hydrogen. The next thing to balance is what?
Oxygen.
Oxygen. We have 3 oxygens and we have 1 oxygen. Tell me, guys, what should I do here? What do you guys think we should do here?
Add 2 waters to the right.
Right, that's true. We should be adding 2 waters on the right-hand side. Guys, look here, please. if you were thinking that this is NO3 minus and this is NO and I see one oxygen, so I should just put a 3 here in the front. You see, if I put a 3 here in the front, I'm not saying we will. If we put a 3 here, then what will happen? Oxygens will be good, but what about nitrogen? Nitrogen will become 3. You'll go back and put a 3 here. Now what do? It's 9 oxygen. What do? You go back and put 9 here. You see, you'll just keep doing that and you'll never get the right answer. Does that make sense, guys?
Yes.
Okay. So you must balance oxygen by adding water, no matter you have oxygen or not on the other side. You must balance oxygen by adding waters. So you added 2 waters. So that's 2 oxygen, 1 oxygen, 3 oxygens total. All right. Now what's next, guys? Our N is good. Oxygen is good. What's next?
Balance to H.
Hydrogen. We have how many hydrogens here?
4.
4. So I should add what here? 4 what? 4
H plus.
4H plus.
4H plus. Yes. Once you add 4H plus, what do we do next? Then you look at the charge.
Balance.
Right. What's the charge on the left hand side?
3 plus.
It's a +3 charge. Does everyone get that? It's +3. It's +4 here and -1 here. That's +3. And what's the charge on this side?
0.
0 charge. So guys, which side should we add electrons and how many?
Left and add like 3.
So we should add 3 electrons on the left hand side, right? So we'll add 3 electrons here to the more positive side. This is +3, this is 0, so we add it to the +3 side. How many? We add 3 so that our charge becomes 0 on both the sides. Same on both the sides. Okay, now, guys, did you look at the checkpoint? Is our checkpoint good?
Yeah.
What was the checkpoint, guys?
Electrons should be on the opposite side.
Positioning.
Should be on the opposite side. Like here, you see it's on the right-hand side of the arrow, and for this one, it's on the left-hand side of the arrow, and that's good. Okay, now what's our next step?
Adding them together.
Before adding them together, we have to make sure of one thing, which is
The electrons are the same.
Yeah.
electrons are the same. So for that, we need to multiply this side by how much?
3.
3. And this side by how much?
2.
2, right? So this 3 times 2 becomes 6 electrons, and this 3 times 2 also becomes 6 electrons. Okay? Right. Now, I guess if you rewrite this, this becomes 3H2S, giving us 3S plus 6H plus 6 electrons. That's our left-hand side. If we do our right-hand side, we times it by 2. That's 6 electrons plus 2NO3 negative plus 8H plus, giving us 2NO and 2 times 4, 2 times 2, 4H2O. All right, are we good, guys? Any questions so far? All right, now what do we do next, guys?
Add them together.
Now we add them together. So what do we add? We take the left-hand side of the arrow and add it to the left-hand side of the arrow. So guys, tell me, you guys will tell me, I'll write what I need to write here. So tell me guys what should write here. Where should I start?
3H2S
So 3H2S.
plus 6 electrons.
Right, so we're done with the left-hand side here. So we go here and then pick the left-hand side, 6 electrons and 2NO3 negative and 8H plus.
Yeah.
Right, so we're done with the left. Now you make the arrow and then you go back here. You start from the right-hand side, which is 3 sulfurs, 6H plus, 6 electrons, and then we go back to the right-hand side, right? So we have 2NO and then 4H2O. Yes, any questions so far? What do we do in this step? No? Okay, now at this point, guys, what do we do here?
You can cancel out the hydrogen.
Cancel out the common.
Cancel the comment. And what should be common? The whole point of doing this so far was to cancel what?
The electrons.
Electrons. So they must cancel. You should verify that they cancel. If anything else cancel, we'll see that too. But electrons must cancel. Okay, now do you see anything else that will cancel?
The
Hydrogen.
hydrogen.
The H pluses. This is 8H plus and this is 6H plus. So all these 6 will be gone. And here you will be left with how many?
2.
With 2. Okay, now anything else that you see cancels? No, right?
No.
So 3H2S plus 2NO3 minus plus 2H plus. And guys, be very careful with these. Sometimes when we see this cancel, and we are doing this in a hurry, especially on exam, we're gonna forget this whole thing together. So remember, just be patient with these problems, okay? Okay, now this is what we have, guys. And can you tell me, first tell me, this is acidic condition or basic so far?
Acidic.
This is acidic. So if the question was balance this is an acidic, you were done. But if the question said basic conditions, then what do you do here?
Add OH
You add OH. Which side do we add OH?
on both.
On both sides. But how many OH minus should we add? And remember, it's OH minus, okay? So be in a good habit of calling it OH minus and not OH, because if you say OH, you will actually forget the charge. So do put OH, do say OH minus, okay? All right. So OH minus carries how many on each side?
2.
2. And the goal is to cancel these 2H plus. That's why we're adding 2 on both the sides. Okay, now guys, if we have to rewrite this, it's 3H2S plus 2NO3 negative. How should I write this next one, guys? 2H plus and 2H minus? When they combine?
4H.
H2O.
Is that 4H2O or 2H2O?
4H2O.
Nope. Thomas? It's 2H2O. Remember, 1H plus and 1 OH minus gives you 1H2O. So 2 of them will give you 2 waters. Okay? So 2H plus and 2H minus come together to give you 2H2O. Yes, that is 4 oxygens, that's true, but it's 2H2O. Does that make sense, guys? Right. Now, on the right-hand side, you have 3S, and you have 2NO, and then you have 4H2O, and then you have 2OH minus. Now, do you see anything else, guys, that that can be canceled here?
Water.
Water. So you have this 2 waters, take off 2 waters from here, so out of 4, you're left with 2H2O. Okay? Now, do you see anything else that can be canceled?
No.
No. So guys, this is what condition?
Basic.
Basic. And that OH minus is indicating that. Guys, can we confirm if it's actually balanced? Because this is one of those questions where you can actually check if you got the right answer or not.
Yeah, you can.
Okay, let's see. How many hydrogens do we have left? 3 times 2, 6. Right hand side, how many hydrogens do we have? You see 2 times 2, 4, and then 2, 6. How many sulfurs? We got 3 sulfurs, and we got 3 sulfurs. We got 2 nitrogens on the left hand side. We got 2 nitrogens. And if we look for oxygen, it's 2 times 3 is 6. And if you see here, that's 2 here, 2 here, and 2 here. That's also 6. Are we good here, guys?
Mm-hmm.
Okay, now tell me, is our charge good? Because that's also important.
Yeah.
So what's the charge on the left hand side here?
-1.
Nope. It's negative
Oh,
1,
-2.
but there are 2 of them, so -2. And what's the charge on the right hand side?
-2.
-2, because you see it's -1 OH minus, but there are 2 of them, so it's -2. So our atoms match and our charges match, and that's when you're done. Okay. Right. Right, questions, guys?
No.
No questions? Okay. Is questions about anything else in general? About lab or lecture?
Oh, is there any calculations to submit for the pre-lab for lab 5?
For lab 5, no. No. You mean for the next lab, right?
Yeah.
No calculation. Only calculation is for the copper concentration lab, you're doing the calculation. For pre-lab, if the pre-lab question has a calculation, you'll have to do it. Let's see if there's any. I don't think so. This is all chemical reactions and stuff. There should be like no math in here. Yeah. It's more on ionic equations. How is net ionic different from complete ionic and stuff like that. Okay. Right. Any more questions, guys?
I have a question in class in general. I got an email from Mount SAC saying that they're going to switch over to pass or no pass. What is that about?
That's up to you. So you will get the regular grades from us. And at the end of the semester, if you decide that you want to take a pass, no pass, you can change it to pass, no pass. Okay?
Oh,
but we will give you a regular grade, like a letter grade.
Oh, okay.
But you will have that very last week to decide if you want to switch it to a pass, no pass.
Do you know? Oh, sorry.
Yeah.
So if it's pass or no pass, how does that affect like your overall GPA?
I think pass no pass has no effect on your GPA, so your GPA will stay as it is.
Oh, okay.
Yeah. As far as I know, yes. Anyone else want to comment on that?
I actually just had a question.
Yeah.
So for the pass no pass, do you know if universities are accepting it, or do we have to retake it there?
For only this semester, I think UC and Cal State, both of them have said that they're going to be accepting, I think, pass no pass, and they're going to be accepting the online labs like we're doing it now. So, but again, you want to still confirm that with your school specifically.
Okay.
Or maybe ask the counselor. Okay.
Thank you.
Right. Any more questions, guys? Right. For now, guys, I'm gonna end the meeting here, and then you're gonna find the recording for this on Canvas. Okay.
Thanks, Mom.
All right. See you guys. Take care.
Thank you.